So today we're going to be looking at evaluating functions. This is very important in any of the algebra that we do. We have to know how to evaluate a function with a given value. So step one is to substitute a value in for x, or f of x. So f of x, if we remember from algebra 1, is just like y. It's just another way of saying y, which is the output of the function. X is usually always the input. Step 2, simplify, so we're using order of operations. And then step 3 is write the solution in function notation, which I will go over here in a little bit in this first example. So example number 1 says evaluate the following functions. So f of x equals negative x plus 5 times x squared. And then we have to evaluate it at x equals negative 1. So all we're doing is we're taking this negative 1 value and we're plugging it in for all of these x's. So f of negative 1. So really what this is a y value. That's what we're looking for at the end. So this really does nothing. Don't think it's any kind of multiplier or anything like that. So we're just plugging in. So negative, and whenever I plug in values to a function, I always like to put parentheses, especially if there's negative signs. So negative 1 goes in there, plus 5 times, so I'm going to do another parenthesis because we're subbing a value in for x. Negative 1 goes in there. So now we have, instead of x squared, we have negative 1 squared. So now we just simplify. So step 2. So negative 1, so that's the opposite of negative 1, so that would be a positive 1. And then we're adding 5 times negative 1 squared. So negative 1 squared, we have to remember, is negative 1 times negative 1, which would be a positive 1. So we end up with 5 times 1, which we know is 5. We have to follow order of operations, so we're multiplying first. So that's 5, and then we're just adding on that 1, and we end up with 6. Example B, so g of x. So g of x is, again, just another way of saying y, but it's in function notation. So the same thing that we did here, it's just another type of function. We're plugging in this 2 in for all of our x's. So there and there, we're plugging this 2 in. So g of 2, so we're evaluating function g at x equals 2. So 3 times 2 to the third power plus 4 times 2, then minus 5. So now we have to remember order of operations. Remember, in this particular problem, this exponent is the first thing that we have to deal with. So this 2 to the third power. So remember, 2 to the third power is 2 times 2 times 2. So that's going to be 8. So this first part we have 3 times 8 plus, now we can do this multiplication. 4 times 2, that's going to be 8, and then minus 5. So now we have to take care of this 3 times 8, so 24. 8 minus 5, that's going to be a positive 3. So I'm going to write plus 3. And then the final answer would be 27. So we could set that equal to this g of 2. That is our output. When x is 2, our y value is going to be 27. So now we have this other one, this last one. So g of x equals 4x plus 6 over 2x. So again, we're plugging this 3 into all the x's. So g of 3 equals 4 times 3. And we can just write this in here if it's not negative. Plus 6. And then all over 2 times 3. So we're going to do the multiplication first. So 4 times 3. So it's 12. It's equal, and then plus 6 all over 6. So 2 times 3 is 6. And now we have to add up here first. So we're going to get 18 divided by 6, which the final answer would be 3. So that's the final answer there. So g of 3 equals 3. So pause right now and try the checkpoints, and then I'm going to work through these. So -1 plugs in. So we're going to have f of -1 equals. So 2 times -1 squared minus a -1 plus 1. So now order of operations, we have to do exponent first. So -1 squared is 1 times 2 would be just 2. And -1 is a positive 1. And then the plus 1 comes down. So 2 plus 1 plus 1 is 4. So final answer would be 4. F of -1 is 4. Or y equals 4. That's the same thing. So now it says, what is g of 1 when this is our function? So it's the same thing. It's just a different way of asking. But the 1 goes into all the x's. So g of 1 equals, we have 1 squared minus 1 all over 1. So we plug 1 in, we get, so 1 squared is 1 minus 1 is 0. And then that would be over 1. So we end up with 0 as our answer. Moving down to example 2. So we are finding the input now when we have a given output. So they're giving us a y value, and we are finding the x value. So we're plugging this 31 right here. That says it's equivalent to f of x. So what we're doing is we're replacing our f of x with 31. So our y is getting replaced. So 31 goes in that spot, and then we just have the function 6x minus 5. And now we're finding x. That's what it wants, is find x. So we're going to solve for x, just like we did in Algebra 1. So first thing, you're going to add 5 over. We get 36 equals 6x divided by, so 36 divided by 6 is going to be 6. Final answer is 6. And then b, g of t equals 2t plus 9. Find t when g of t equals 15. So same thing we did up here in a. We're going to take 15, and we're going to replace g of t with it. So 15 equals 2t plus 9. So this one now solve for t. Subtract 9, so we get 6 equals 2t. And then divide by 2, we get t equals 3. That's it. So pause now, do the checkpoints, and then I will go over these. So this one, they give us f of x is 19. So we're doing the same thing we did in a and b. We're plugging 19 in and replacing f of x with it. So 19 equals negative 3x plus 4. We're going to subtract 4. So we get 15 equals a negative 3x. Divide by negative 3, and we end up with x equals negative 5. And number 4, f of t equals 2t plus 5. So finding t when f of t is 13, so that goes here. And then 2t plus 5, now we solve for t. So first thing we're going to do is get rid of this 5 by subtracting. So 13 minus 5 is 8 equals 2t, and then t equals, so 8 divided by 2 is 4. And that's that. And then second page. Next type that you will see, solve for the indicated variable. So if f of x is this function, and f of 2 equals 5, what is the value of a? So this is a little bit different. We have a coefficient missing here that we need to solve for. So what we're going to do is we're going to plug the given information into the function. So they tell us f of 2 is 5. So that means when x is 5, y is, or sorry, when x is 2, the y value is going to be 5. So we're going to combine the first two examples kind of together. So 5 goes where f of x is, and then we're plugging 2 in for all of the x values. So we're going to say 2 times 2 cubed plus a, that's the thing we need to find. And here's the x, so 2 squared, and then plus 4 times 2, and minus 5. So now that we have our y value plugged in and then we have the x's plugged in, now we can solve for a. So the first thing we need to do is clean this up a little bit and use our order of operations. So I'm just going to move this negative 5 out of the way. We need to get rid of this. So if I want to move it to the other side, we know that we want a by itself at the end. So all I have to do is add 5 to the other side. So now I have 10 on the left side. And this thing is gone. And now we can handle these three terms. So the first one I want to deal with is the 2 to the third, which is 8. So 2 times 8 is 16, plus 2 squared, that's 4, times a, that's going to be 4a. Okay, you could have said a4, but usually we write our numbers that we know in front of variables. And then plus 4 times 2, that's 8. Now we can clean this up. 16 plus 8 is 24, plus 4a minus 10, or no, not minus 10, equals 10. And then we're going to subtract 24. So subtracting 24 will give us negative 14 equals 4a. And divide by 4, we get negative 14 over 4, which reduces to negative 7 over 2. So we get a negative 7/2 for our answer. So pause now, do the checkpoint. I'll go through it. So they tell us the function f, and then they say when f of 0 is 2. So when x is 0, y is 2. So we're going to plug that in. So 2 goes where f of x was. And then we plug in 0. So 3 times 0 plus 8 and 2 times 0 minus a. Clean it up a little bit before we deal with it. So 3 times 0 and 2 times 0, we know those are zeros, right? So now we just have this. We have 2 equals 8 over negative a. Now here's a special situation where, you know, there's a lot of mistakes. The variable is on the bottom of the fraction. So what we want to do, and there is a shortcut which you'll see what it is after we're all done, but I want to just multiply this like we normally would. If I was getting rid of this number, since how it is dividing 8, I need to go ahead and multiply both sides by negative a. So we end up with 2 times negative a equals 8. Now we can go ahead and divide by 2. We can get rid of this 2 because we know we want a by itself. The problem with, we couldn't leave it over here because it was on the bottom. So we're going to do a little more work. So negative a is going to equal 4. But remember, we don't want negative a, we want a. So a, we divide or multiply by negative 1, and we end up with a negative 4. And that's that. So example 4, evaluate the functions using the graph provided. So we are looking over at this graph and we're going to be able to evaluate functions, something that you've been dealing with graphs for quite some time in math. It's just a question of knowing what they're asking and what they're giving. So f of negative 1, so they give us the x value. So negative 1, what they want to know is what the y value is. So when x is negative 1, so we go over here to the graph and we go to negative 1, we move up until we hit the graph and we have a y value of 3. So not too bad. So now x value is 5. They want to know the y value, so go over to 5 on the x and then up to the function, and the y value is 5. C, f of x equals 4. So they tell us now that the y value is 4. And they want to know what the x value is, so it's the opposite. So if we go to 4 on the y, and we go over to the function, so if I go over to where 4 hits the function, now I have a value of x is 4. But we have to be really careful on this, because if I look and I were to think of a line going all the way across both sides, look at how many times it touches the blue function. It touches 3 times. So not only do we have an x value of 4 here, we have another x value of 6. And then on the left side, we have an x value of negative 5. So we actually have 3 answers. So be very careful. Looking at f of x equals 1. So we want to know which x value provides us a y value of 1. So again, we go to the 1 on the y and we follow it all the way left and all the way right and see where it hits. So we hit here, so that is an x value of 1. If we continue on, it doesn't hit anything over here. So we're good on the right side. Now we got to look on the left. Over here, we hit at negative 2. And if we keep going, we hit at negative 8. So negative 2 and negative 8. Example 5. So we're evaluating a function from a given table. So this is pretty much the same thing we just looked at on the graph, but it's in table form. So you're thinking the same thing. In this, you have a given x value. So f of 0, that means we have an x, and we want to know the y. So 0, we go over here to the table and we look at x's, and where do we have a 0? Right here. And all we have to do is look at the associated y value. So that's negative 1. So when x is 0, we have a y value of negative 1. F of 3, we go to the x and we go over to 3. What's the y value? It's 5. And then C, f of x equals 3. So remember, anytime it says this, it's actually saying what the y value is. And they want to know that x. So f of x is 3, so we have to go on the f of x line and go over to 3. And then we go up to the x value, and that is a -1. So go ahead and do the checkpoint, pause it, and then come back. So f of 8. X is 8, so right here, and then the associated y value is 11. F of x equals -1, so we're looking at a y is -1, and then the x value is 1. And then again, they want an x value when given a y, so go over to the y. F of x is 4 when x is -2. Example 6. So 2 more to go. Baby Kara's parents measure her height every month. H of t models Kara's height in centimeters when she was 10 months old. Or, sorry, not 10 months, t months old. What does the statement h of 160 equals 150 mean? Well, before we can start, we need to figure out what is what. So if we look at the given name, h of t, so t represents time, okay? So time, it tells us right there, 10 months old. So 160 is in the same spot as t, so we can say that that is 160 months. Sorry, it is really hard writing with a mouse. Sorry, 160 months old. And then the 150 is the output. So the output, it tells us, it models the height in centimeters. So the 150 is going to mean 150 centimeters. And that's it. Example 7. Harry took a loan from the bank. D of t models Harry's remaining debt in dollars as a function of time in months. The function to model the situation is given as d of t equals -200t plus 9,000. So what was the size of Harry's loan? So if we think back to Algebra 1 or any pre-algebra that we've done, we do know that this is the y-intercept. So what that means, if you don't remember, if I were to plug a 0 months, so right at the beginning of the loan is 0 months. So if I plug in 0 for t, think about what happens. -200 times 0, that would be 0, plus 9,000. So right at the beginning, there's $9,000 in the account. Okay, so that's what his loan was. He borrowed $9,000. And then how much does Harry pay towards his loan each month? So if we know that this is slope, this -200, we could say that it goes down $200 every month. Or if we use logic and we plug 1 month in here, that'd be 1 times -200, and we would take that off of 9,000. And we would end up with 8,800. If we were to plug a 2 in for t, that would be a -400. So after 2 months, he's paid $400. So that would go down to 8,600. So just using logic, we can figure out that it is $200 is what the payment is every month. So 200. Okay. So I might want to say, let's say dollars on both of these. And that's it for section 1.1.